Every executive is saying, what should we do about AI? What's happening with AI? I'm Raj De Datta. I'm CEO and co-founder of Bloomreach, and I'm excited to be joined in this conversation by Xun, our CTO, who's going to tell us from his perspective what the future of AI looks like. Xun, welcome to this conversation.
Yeah, excited to be here talking with my best friend here, Raj, about the journey of AI.
All right. Well, in a world where machines are ever present in our lives, present in every workflow in many ways. Xun, my question for you is this. Before we talk about AI, I want to know what human skill you and your team have developed because of AI.
Well, the way I think about it, Raj, is that the most important skill for us to have as engineers here at Bloomreach is the skill to adapt and the skill to experiment. I think what we've seen is that technology is just moving so quickly these days. Every single month, there's a new innovation, a new way to do things. And it seems that the most useful skill, most of all, in this day and age, is the skill to adapt.
That makes total sense. I mean, I think I might even say that's true beyond engineering. Like increasingly, we're entering a world of multidimensional learners and generalists. This idea of extreme specialization where I am the best in the world at X, Y, or Z. And if the topic goes beyond that, well, pass the buck to someone else. It feels like AI is not going to be the kind of technology where that kind of individual succeeds.
Yeah, that's very true. I mean, AI gives us all superpowers, but we have to be willing to accept the usage of those superpowers. We can't be sort of held back by what used to work in the past, what we're very used to. We need to be able to embrace change.
Yep.
And that, I think, is more so than a skill. It's almost a mindset where you've got to train yourself to really adopt that mindset. Because we as humans, we tend to not like change.
Right.
You have to force yourself to be able to go and read the latest innovation, try it out with your own hands, and not just ignore it and do the same old thing that you used to do because it used to work well. That is really the age that we're living in today.
Isn't that so tough when everybody has deadlines, deliverables, stuff they have to continue to build? So I can imagine that when I show up, when you show up, and when we go to our teams and when we say, look, we expect you to be reading about the latest AI. We expect you to be using the latest tools. They're like, hold up, Xun. I have to ship my project. I have to make sure that I continue to deliver on time. I have to make sure that we continue to add value for our customers. How do we do all of that and learn about the latest and greatest AI thing that you're posting about?
Yeah, I think that's where we need a certain level of maturity as well as individuals and as engineers to understand how to balance the trade-off between immediate deliverables versus investment in our own training, in our own learning, right? And it is the case that, we expect as leaders that, very seasoned individual contributors, engineers, even other leaders, that they come back and tell us, hey, maybe it's not so good for us to aim for this particular deadline because I need to retrain and get my team the tools to enable us to move even faster.
Yep.
And it is just important for leaders especially to be proactive about that so that we know where the investment is needed. Because unless we go and retrain and be latest with the latest technology, with the latest workflows, with the latest style of thinking, then we'll always be behind. And we've got to be in front of everything.
Yeah. It's interesting when I've been meeting with some of the AI native early stage companies, they say it's not just about the mindset of the individual, it's about the change in the system. And I'm interested in your take on this. And many teams that I talk to talk about how they can go from design to prototype to early code to validate product market fit, and then ultimately to ship something at a rate that's incredible. But to do that, you can't just have the product manager say, I'm going to take 4 weeks to go write a PRD or a product requirements document. I'm going to have the designer take 2 weeks to go create a design, and then I'm going to do a prototype. All those time frames have been compressed That's what I hear from the earliest stage tech companies who are getting going. Do you think that's true even in larger organizations that are trying to undertake this kind of AI transformation?
Yeah, absolutely. I feel that the AI transformation is very aligned to the agile development methodology. The more agile a company is and the development team is, the more the ability for us to be able to stay on top of things. So yes, and at Bloomreach here, we have currently a 6-week development cycle. That allows us to be very quick in terms of reprioritizing things. If there is a trade-off between learning and investment, then we can quickly turn that around and sort of complete the design, the product thinking, the development, the QA, and the deployment within that 6-week cycle.
Yeah.
So being fast allows us to go and really leverage the AI capabilities that are available so that we can use it to increase the velocity and capacity of our engineering organization.
So Xun, we've been on this AI journey for a couple of years, and you've been on the AI journey in many ways for much beyond that. So what I wanted to talk to you about is AI in 2025 versus AI, say, when ChatGPT came out. So when people think about the state of AI and the capabilities of AI models around the time when ChatGPT hit the scene versus what's possible here today with the latest models, how would you describe the difference?
Well, what we've seen so far is that the AI that is evolved from ChatGPT is still in essence the same architecture, which is the transformer architecture. That has, given us a long runway in order to innovate. But we've seen broadly two things happen. The first is that we've realized that training data is maybe more important than just architecture. So what you see is that the ability to go and build useful language models, like generative models, or even just useful any kind of models, is really based on the quality of the data that you put into it.
Yep.
So there's been a lot of more focus in making the data a lot more better. And then by doing that, you gain a lot of efficiency in the model itself. So before, you may need like a 100 billion parameter model to output a certain quality level.
Yeah.
Today, you can get that same quality level that we got 2 years ago with an 8 billion parameter model, something that can even just run on your laptop.
A new kind of Moore's law in some sense, as the number of parameters you need to train a model comes down.
That's right. That's right. So that's one factor that we've seen. The second factor we've seen, especially in the generative model arena, is the ability for the models to better reason. When ChatGPT first came out, we call that a system one style thinking,
Yep.
which is kind of mapped to human intuition. Sort of like if someone just asks you, what is the capital of France? You don't really need to think about it. You just go, oh, it's Paris, right? But what we've seen is that for more difficult problems, especially those that require mathematics, higher order problem solving, you can't just rely on intuition alone. So what we've seen in the past 2 years is this ability for us to use the models in a way that forces them to do longer thinking. And we call that system 2 thinking. And that's given the rise to a new set of models and even a new terminology called LRMs. So it's not large language models anymore, but large reasoning models.
Yeah, no, I mean, I think that's fascinating. And then I had a professor, Daniel Kahneman, who actually talked a lot about system one and system two type thinking and how human beings often go back and forth between those two types of tasks. And actually, most of what we learn in school is system two thinking. We do these very analytical problems, but so much of what we do in our day-to-day life is system one, type thinking. And what's interesting to me about this kind of evolution of AI is that it probably means that AI can be that much more pervasive in our lives. Because if it's narrow in its application, then it's a purpose-built tool to go do something specific. If it starts to be able to reason, if it starts to be able to make sense of simple decisions, judgment-based decisions, less quantifiable decisions, and the analytical decisions, then it has a much wider set of applicability.
That's exactly right. And to just give a plug with our own product, our Affinity product, That's exactly what we're leveraging. We're leveraging the system 2 level thinking to mimic the way the marketers think and reason about using analytical data from our vast wealth of user behavior, getting that information, synthesizing it, matching that with marketing best practices, and then matching that with how to build a marketing automation on behalf of our user. And that's what Affinity is. It's an agent that utilizes reasoning to be able to go and accomplish the tasks of marketing
Of
automation.
marketing makes sense. I mean, where I might want to, for example, launch a new line of snowboards, and it's unclear exactly how I might go about doing that. And so the reasoning steps around the launch that translate from the product to the copy to the campaign to the timing to the cohort of customers I should launch it to, all of those require fairly complex reasoning to go make happen. The other trend that I see in our products, and I'm interested in whether you think it's more generalizable, is that we have historically prompted models in a chained manner, almost making micro calls to the large language models to accomplish a larger task. It feels like the models are starting to get more powerful, where I can ask it to process these larger, bigger goals, and it can come back and actually determine what the steps are. Is that one of the outputs of reasoning?
I would say that that is more related to how we're using these models in general. Before, it's more of a thinking and a paradigm shift more than I think that it's about reasoning.
Okay.
There's one paradigm which feels that, you need to really constrain and control the model, that you need to build static workflows
Yep.
towards the model. So that is, I would say, a matter of the agent philosophy. You can have an agent philosophy that is, hey, I'm going to control exactly what the agent does. They're going to do agent step A, step B, step C.
More deterministic.
It's more deterministic, right? And that might work well for certain types of businesses where you need the determinism. You don't want to go off the rails and do F, G, Z and go around. For some businesses, it makes sense to always do an ordered workflow from A to B, right?
Yeah.
But there are other use cases, and we've seen that with our conversational use case, where you want the model.
You want it to flow.
You want it to flow, exactly. If you want it to flow, then the paradigm that you should seek is let the model figure it out.
Yeah, that makes sense. I think I've seen applications that are in the flow case. And then there's, to give an example of where determinism is really important, imagine you're in a healthcare application or a financial application that's highly regulated, where there might be HIPAA compliance or where there might be other regulatory compliance that's required. Now, you don't want the model to go off course in terms of the steps it follows. And so there's still a place for determinism in that process.
Exactly right.
The last question I wanted to ask you on the technology side is just the orders of magnitude of how costs have changed. When we look at the amount of processing, the tokens, and the cost, it feels like it's like order of magnitude different today than it was 2 years ago. Is that fair to say?
It's fair to say, but we're also seeing sort of more we can do when you add more cost. So the things that you used to be able to do with ChatGPT 3, you're absolutely right. The cost of that has dropped dramatically by an order of magnitude. But what we've also found in the industry is that what we call test time compute, which is the ability to do more computation at inference time,
Yep.
gives you even newer emergent properties.
Yep. Yep. So the technology evolves. The stuff we used to do before is a lot cheaper than it ever was. But then there opens up a whole new wide range of applications because of the current generation of models, which remain expensive.
That's right.
So Xun, one of the questions that is, of course, the ever-present question is AI taking jobs. So, we've seen what's happened with Cursor. We've seen what's happened with all the dev tools that are out there. The number one in the center of the bullseye is the software engineer. So let me ask you directly, is AI taking away software engineering jobs?
Well, the way I think about it right now is that AI will eventually be able to replace any job, but it is a long time horizon. And what is important is knowing where we are on that time horizon. It is not the case that today the AI can take complete software engineering job. I mean, the best, even the latest cursor with the latest agent technology and latest models, we see that even in benchmarks, it only scores 80-something%. And that's on benchmarks. That's not even a specific custom use case. So we're still quite some time away from it being able to completely replace a software engineer. What we do know is that it absolutely can increase the productivity of software engineering.
Yeah.
And there's much more than just generating code that is in the everyday life of software engineers.
Yeah.
We've done surveys to look at what is the breakdown of time you as a software engineer actually spend up doing. And code generation sometimes even is as low as 25% to as high as 50%. Because there's a lot of work that you need to do as part of an engineer's responsibilities that is not just about writing code. Even when you even think about what is the difference between an software engineer, the term engineering itself.
Yeah.
Engineering is not just about writing code.
Yeah.
It's about building, architecting, documenting, making sure that things are tested. The thing that I always tell my engineers is that, let's forget about software and technology, but let's talk about what engineering is about. Let's go look at a bridge. Now, someone built this bridge, and this bridge has lasted 50 years.
Yeah. And so we're building a digital version of a bridge. And
That's right. That's right. And the discipline that you need to build a bridge that lasts 50 years is much more than the construction of building that bridge.
that makes
It is
sense.
about planning. It is about testing. It is about mathematics. It's about design. So we can see that there's many different roles and phases to really be able to build a system that stands the test of time, is highly scalable, highly reliable, that is far beyond just coding.
Makes sense. Yeah. I will go on record as saying that AI is going to actually end up creating a boom in jobs and not take away jobs. In fact, I think to say that AI will in the end reduce the size of the workforce and will be hanging out on the beach is a bit of an underestimation of human creativity. Because through the history of time, what we know is when one problem gets automated, we invent a whole new set of problems to go solve. And I'm pretty confident that as we get more and more productivity across a wide range of roles, that we're just going to be like, there's another problem to solve and another problem to solve. And that's how human beings have advanced in the history of time. And I see it happening all over again.
Yeah, in fact, I see that what AI will help us be able to do, referring back to a comment you made earlier, is it gives generalization capability so that people can be a generalist. And what I see happening is that we will be able to get the benefits of technology penetrated into many industries where it doesn't
Where it
exist.
doesn't exist. That's true too. Yeah, makes sense. Technology is not going to be a sector of the economy. It's going to be an underpinning of the economy.
Exactly. And that's being enabled by the part where it used to be that you need a 300-person team to go build a solution for this area that is underserved technologically. Now you can have maybe a team of 1 or 2 people leveraging AI to deliver a solution that really helps these niche areas and underserved areas of technology.
Xun, it was so much fun to talk to you today. I really appreciate it, learned a ton. For those of you who are interested in this topic, please subscribe to our YouTube channel. And thanks for tuning in to Face with the Future of AI.